number 21, for part A, we're trying to find an equation in the form y equals a times e to the kt to show this growth of the bacterium. A is the starting amount, t is the time, and y is the ending amount. So in this example, we start off with 10,000 bacteria, and after 10 minutes we have 50,000. So we have 10,000 e to the 10k. K is a constant that we're trying to solve for in order to write our equation. So to do that, we're going to divide both sides by 10,000. I'm going to rearrange this a little bit. We have e to the 10k equals 5. Now, to solve for k, we have to change this to log form. So log base e, or natural log of 5, equals 10k. So divide both sides by 10 to get what k is. We're going to write an approximation, but we want this one to be stored in our calculator. So we have natural log of 5 divided by 10. We get about 0.161. But we're going to need this for some other problems, so we're going to store this value in for x. Now whenever we use x, it's going to use that value. So part A, we get y equals, start off with 10,000 times e to the 0.161 t. So the starting amount doesn't change. The thing that changes is the time, and we can plug in any time now and figure out how many bacteria there are. For part B, we want to figure out how many bacteria there are after 20 minutes. So y equals 10,000 times e to the 0.161 times 20. This whole exponent is going to be in parentheses. So if we do 10,000 times e to the 0.161, we don't want to just put in 0.161, we want to use that whole value. So we stored it for x, we can put in 20x for our exponent. So it's going to take 20 times 0.161, that whole value. And you do that, we should get 250,000. Oops. So 250,000 bacteria after 20 minutes. Finally, for part C, we want to figure out how long does it take for there to be 20,000 bacteria. So that's our ending amount. We're putting that in for y. So basically, we're trying to figure out how long does it take for the bacteria to double. So solving this is going to be kind of like solving in part A. We're going to divide both sides by 10,000. We get e to the 0.161 t equals 2. So now to solve for t, we're going to take the natural log of 2, and that's equal to 0.161 t. So we're going to divide by 0.161, but again, we want to use the whole value that we got earlier. That's why we stored it for x. So we're going to take natural log of 2, close the parentheses, divided by x. And you should get 4.31. Rounded 3 decimals, 4.307. And we're talking about minutes in this problem.